Hi guys, this will be the last part of like this mini series I've been doing for USACO 2020. And for December contest, problem 3, we're going to be doing Stuck in a Rut. This is going to be a bit harder than the other 2 problems that I've done. So, just be ready for that. The code is going to be a bit longer, a bit more convoluted. And we're going to take a bit more time reading the problem and being on the iPad. Okay, let's read the problem as always. Farmer John has recently expanded. Okay, if you can hear my dog in the background, it's fine, just ignore him. Farmer John has recently expanded the size of his farm, so from the perspective of his cows, it is now infinite in size. Cows think of grazing area of the farm as infinite to the grid of squares, each filled with delicious grass. Each of Farmer John's and cows, and is 1 through 50, and starts out with a different cell. Some start facing north and some start facing east. Every hour, the cow either stops if the grass in her current cell was already eaten, or eats all the grass in her current cell and moves 1 cell forward. Okay, over time, each cow therefore leaves a barren rut of empty cells behind her. If cows move in the same grassy cell in the same move, they share the cell and continue moving in their respective directions in the next hour. These determine the amount of grass eaten by each cow. Some cows never stop, and therefore they eat an infinite amount of grass. And so the input is pretty standard. The first line is N, and each of the next N lines describes the location of the cow and the direction that they're facing, either N or E. And just some things to put out here. X and Y are going to be from 0 to 10 to the 9. And all coordinates are distinct from each other, similar for x coordinates. Okay, y coordinates. And to be as clear as possible, if the row cow in a cell xy facing north, she ends up in the cell x comma y plus 1. So you add 1 to the y when you go north. And if you move east, you add 1 to the x coordinate. And for output, print n lines with line I being the output of number of cells of grass that the i's cow ate. So we have 6 cows here, east at 3,5, north at 5,3, east at 4,6, blah, blah, and the outputs are going to be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, with each of these cows eating a certain amount of grass. Okay, just from reading this problem, you could probably tell this problem is going to be a bit more complicated than usual, having to do a bit more thinking, more planning, and this is the kind of stuff that you'll see nowadays for USACO, since it has gotten a lot harder as the year has gone by since 2020. Let's go into the iPad. So actually, what I'm gonna do is make so you can see my face as you're in here. There you go, nice. Okay, that's from the last question. So this problem is called Stuck in a Rut. Okay, stuck in a rut. So I don't know if you can see the grid very well. So let's add a new page here. That has a very distinct grid. Square paper. Okay. That should be better, I think. If not, it should still work. So, okay. Let's say we have some grids here, okay? And each of these grids have a circle in them to show that it still has grass. I'm not going to draw too many because that's going to take a while to show. Okay, let's just copy this. Nice. Okay, so now we have a grid of grass. And what we're going to do here is place a few cows. Let's say this is a north cow, and that's going to be an east cow. And let's say we have a cow here, a cow here, and a cow there. Pretty simple. So when it's been 1 hour, this cow is gonna eat this and move on to here. Let's call this cow 1, cow 2, and cow 3. And this cow is gonna move to here, and this is gonna move to here. Nice, simple stuff. The next thing that's gonna happen, as you can imagine, go here, and finally go here. Nice. Let's move another hour. This cow moves to here, but number 1 now goes on to here. And 3 goes on to here. Okay, for now, all good, okay? But the next turn is where it gets interesting. 2 moves on as normal, but 1 is at a spot that was already eaten. So 1 stops. It stops moving now. And 3, it's at a spot it's already eaten, so it stops as well, just like number 1 did. And 2, as you could probably imagine, keeps going forever to infinity. So what will be the output here, right? 1, 2, and 3. Their outputs are gonna be 1, 8, 1, 2, and 3 units of grass. So 1 gets an output of 3. And 2 here, 1 and 2 units, so it's gonna output of 2. And 3, no, what am I saying? 2 ate an infinite amount of grass, so 2 gets infinity. Infinity. Nice. And 3 here, 8, 1, 2, 3 boxes of glass, so it gets 3. So in this case, the output would be 3, infinity, 3. Okay, now let's try to figure out what we're gonna do for the code of this, right? So looking at this, the first thing that I'm thinking is we should probably divide the cows by north and the east. Now here's the reason why. If we were to have certain number of cows, okay, let's make this grid again. I'm just going to copy a bunch so that it's a bit faster. Let's say we have this grid and we have 2 cows. Actually, I'm going to copy this and put it to the side because we're probably going to use it again. And I don't want to make that every time. Okay, let's say we have cow that goes east, right? Blue as normal, and it takes this square. Another one that takes this square. What you'll notice is goes to infinity, goes to infinity. They never intersect. Obviously, they're parallel, so they will never intersect. So what we could see from this is that an east cow could never interact with the east cow. And that goes the same for a north cow, right? If we were to have this empty field, a north cow and a north cow, they're never going to intersect. They're also parallel. So we could have 2 statements here that we know for true. 2 cows of same direction can never intersect. Intersect. Forgive me for my spelling, not the best. And from this follows not 2 cows, but any cows of the same direction can never intersect, right? That's the first thing that we need to realize here. Let's think of the second thing. When cows intersect, let me just illustrate this before saying it out loud. When cows intersect here, let's use a different color. Intersect here. This is a distance of 2, and this is also a distance of 2. As seen in the problem here, when they are, what does it say? Yes, if 2 cows move into the same grassy field in the same move, they share the cell and continue moving. So in this case, it keeps on going, right? So if cows are same distance from intersection, they keep going. Okay, now let's see what else you would need. Okay, if they're the same direction, they keep going. But what if they're not the same direction? What happens then? Let's clear this up and see what happens. So let's say blue was here, and let's say red was here. Okay, blue here goes first hour, red goes here first hour, blue here and red here, and finally blue here and red here. In this case, blue keeps going and red cannot keep going. It stops there. So distance here is going to be distance of 2, and distance here is going to be distance of 3. So the third thing that we could realize here, cow that is farther away stops going at an intersection. Cow that is further stops at an intersection. Intersection. Okay, so cow that is further stops at an intersection. That's gonna be like the main 3 things that we need to realize about this problem. 1, any cows of the same direction can never intersect. If they intersect, if they're of the same distance, they keep going. And cow that is further stops at that intersection. Okay, nice. Let's try to make this code work. Let's say we have 2 lists, okay? A list of north cows and a list of east cows. Actually, yeah, that's the right color. Okay. North cows, let's say we have cow 1, which we could label with coordinates, right? Coordinate 1, coordinate 2, blah, blah, blah. Ultimately, we go to coordinate n. And we have coordinate 1, coordinate 2, all the way to coordinate n. Now, how are we gonna see if 2 cows intersect and what happens when they intersect, right? How we're gonna look at this is gonna be just matching 2 cows and seeing if they intersect at all. So we're gonna use coordinate 1 cow and coordinate 1 cow and see if they intersect. And do the same coordinate 1 cow, coordinate 2 cow, the blah blah, all the way to coordinate n cow. And after that, we're gonna see if coordinate 2 cow connects with this one, and this one, blah blah, all the way we connect to this one. Right? So that's gonna be our main strategy for how we're gonna go look at this problem. So let's see what that let's look at what that looks like. Let's move on to this grid. I'm making a copy of it as well. Okay, if we look at this grid here, I'll just make a new one right here. If we look at this grid here, if we have cows going like this, those are all east cows, or no, I guess I would use a different color. Those are all east cows, and there was a north cow, right? We're just gonna do a quick thing where we're gonna sort these coordinates by smallest to least, like the smallest to greatest, okay? So let's say we label these cows, cow 1, 2, 3, 4, and cow 1 and 2. So the reason for this is that this cow could block a cow that would otherwise get hit by this one. Like for example, if we were to have a cow that's like here, let's say, another cow that's here and here, what could happen, wait, let's see, okay. What could happen is that this cow goes to here, here, and this cow goes here, here, right? And now this gets blocked, so this stops moving. So this could keep on going. If this cow wasn't there, like this, then what might happen is that this could have gotten blocked. What might have happened is that this cow could have gotten blocked and it wouldn't have been able to go along if that cow wasn't there. So what we're gonna say is we're gonna go always look at the cows from left to right and bottom to up, just so that those intersections don't get too convoluted. Okay, so let's look at this system. We're gonna start with cow 1, okay? And we're gonna basically just choose one of the cows, cow 1, okay? These two cows are what we're looking at right now. Distance to where they would intersect if they did intersect is here. Distance of 1 and distance of 3. Obviously, this one is greater, right? So if you look at this here, the cow that is further stops at the intersection, right? So cow 1 here would stop. Okay, fair enough. It goes here and stops. And cow 1 could keep going. Now let's get cow 2 with cow 1. They go and go. What we could see here is that the distance here is 3, distance here is 2. This is greater this time. So what would happen is they would go, and this will go, and this won't get stopped. And so we're done with cow 1, time to move on to cow 2. When this got blocked, we're gonna set some Boolean thing to say that cow 1 is stopped. So we're gonna not count that anymore. So we're gonna look at cow 2 and this 2. Distance here is distance of 3, distance here, distance of 3. So they keep going by condition number 1. Condition number 2. Same distance, they keep going. So they keep going. This cow keeps going, this cow keeps going. Now let's get 3 and 2. So this is gonna be a distance of 5, and it's gonna be a distance of 4. And so this one gets stopped right here. But 2 keeps on going. Let's get 2 and 4. This is a distance of 4, and this is a distance of 5. And so obviously here 2 gets stopped and 4 keeps on going. Okay, that kind of whole thing made sense, right? So what we're gonna see here is tally up the whole distance of everything. Is we're gonna see cow 1 go all the way to here, cow 2 make it to here. No, cow 1, and this cow 2 is gonna make it all the way past to infinity. Cow 3 makes it to here. Cow 4 makes it to infinity. And cow 2, that goes vertically, keeps on going, and they get stopped right there. Awesome. So let's count up how many each of these cows ate. Let's look at the eastward cows first. Cow 1 ate 3 in total. Cow 2 ate 3 in total. Cow 3 ate 5 in total. Okay, the dog is being loud, but it's fine. And cow 4 ate infinity. Let's look at the north cows. Cow 1 ate 3 in total, including its original square, 1, 2, 3. And cow 2 ate 1, 2, 3, 4, 5 in total. So like this, we could find the answer to the question, and we'll just, put this back the way it was and print it just like that. Okay, I think that is like the explanation of the system that we're gonna take to solve this problem, and let's try to implement this. This is gonna take a while. don't know. I might split this video up into two. If that is so, I'll say bye-bye for now, and I'll see you next week. If not, let's keep going. Okay, just in case I split this up, hello, this is going to be the second part of the last part of this series I've been doing for December 2020. Today we're solving StuckInARut.java. And since we thought of the algorithm last week, we're going to be just implementing it today. Okay, if I didn't got that was slightly awkward. The name of the problem is StuckInARut. StuckInARut. And as always, I'm going to put the code in the description as well as the setup. StuckInARut. Nice. Let's get rid of all these. We don't need these open. These are other questions that I did. Okay, as always, let's start with the input. And the input is going to be, first line is n. Alright. And 10 equals such. And the next n lines is going to be en for n lines. Okay, this time we're going to do something a bit more different, I guess. So hang on for that. But for now, just as you would, most obviously, equals new int array of n, comma 3. For int equals to 0, I split n, I plus plus. And we're going to do input I, comma 0 is equal to tokenizer the next token. Okay, now giving the error. No, I guess. Okay. Let's just do this so that it's not complicated. And input of I, comma 1 is going to be a number, but let's just put a string in. And finally, the last one is going to be like such. Okay. And what we're also going to do is we're going to count the number of n's and s's for, no, n's, e and n's for later. North equals to 0, int east equals to 0. If input I0 is equal to n north plus plus, else it's going to be south, so no, east, so east plus plus. Okay, and you know, that's simple stuff. Okay, now that we have this, we're going to do something a bit different. So in each of these inputs, we have 3 values, and one of these values is the direction and 2 of these are the coordinate, right? We're just going to make a class called coordinate to make this whole thing easier. Class coordinate and public for is int x, int y, and we're going to do this dot x equals to x, this dot y equals to y. I think that's it. I don't exactly remember because I haven't done this in a while. In Java, let me double check real quick. Yes, that is correct. Okay, so that is like gonna be how we're gonna be making classes. If you haven't seen this before, it's called the constructor. It's basically how we make new object types or data types in CS. It's applicable for almost every single type of object-oriented programming, so you should know about this. So we have this coordinate file, a coordinate data type, and what I'm gonna do is, yeah, that's gonna be it. Okay, so we're gonna do next is we're gonna make a list, right? And this is gonna be a list of coordinates, okay? Coordinate list equals to x equals to new coordinate array of n, or not n, east. And let's actually call this east cows. And we're going to do the same thing for north. Nice. And what we're going to do is go from I to n and take inputs here so that if that is equal to n, then 0 equals to, no, what am I saying? Dot z, no, what? Dot x is equal to x, or in this case, x is equal to this, and y is equal to this. And like that. And that's gonna be south cows. East. Okay, I'm keep on mixing up south and east. I don't know what's happening. It's fine. Okay. And for this number, we're just gonna do a count. North count. And we'll just make another one called south count, let's say. And north count plus plus, and south. I put south again. What am I doing? I'm actually going crazy. I've been coding for too long. I've recorded all 3 of these videos back to back. Okay. Why is that giving an error? Oh, it needs to be a int. Percent. And let's put that there too. Okay, that makes sense. 1 and 2. Okay, finally, we're done with our input. And this took a lot longer than this would usually take for a simple problem. So this, tells you that this problem is a bit more complicated. And the logic is going to be a bit more complicated too. So I'm probably going to make this an hour-long video. Okay, fine. Okay. Logic. This is like the scary part of the problem where I'm gonna make a million mistakes and I have to debug it later. Hopefully I didn't make a mistake up here. It should be fine. Okay, as I said before, we're gonna look at all the cows. Goes from left to right and bottom to up, okay? So for int I goes to 0, I is gonna be less than north. I mean, not north. East. E equals to 0. E is less than north. E plus plus. And let's see what happens here. So, there's something I didn't mention actually. If a cow that's north is here, and something that's east is here, obviously they're not going to intersect, right? So we need to account for that too. If these cows I dot x is greater than the north cow, dot x, then they're never going to intersect, okay? So we'll just do continue. And instead of having to write this every single time, what I'm just going to do here is core, I'm just going to do east, but what's the easy name? Let's just do a x. That would be like a fast thing to type. For these kind of things that I need to type a million times, I like to just have a short variable name for them that I could just use. So x comma x and y comma y dot x. Okay, continue. Nice. Now that we've accounted for that, we need to see when they're gonna intersect. Okay, my computer's gonna run out of battery. Let me charge it real quick. It's fine. My camera fell down too. Oh my. Okay. Let's charge my computer real quick. Where's my charger? Alright guys, here is Daniel called Crazy welding CS for too many hours. Okay. Okay, there we go. Computer's charging. Okay, okay, I don't want to. Okay, there you go. Okay, so we have this, and the next thing we're gonna do is find a coordinate where they intersect. And how we're gonna do this is, let's go to the iPad again. Gonna work. Okay, iPad has stopped working, so great, awesome. Let's just go to here and do it. So what we're gonna see here is if we have, let's see, 4, 4, 3, 2, 1, and here 1, 2, 3, 4, 5. If we have a cow that's it here, let's call this east and north here. The coordinate where they intersect, which is here, is gonna be the y coordinate of the east cow and the x coordinate of the north cow, right? That makes sense. So what we're gonna say is coordinate intersect wait. I think this is spell intersect equals to new coordinate of, I said that it's gonna be the east coordinates y-axis, so x dot y and y comma x, y dot x. Awesome, that's not confusing at all. Actually, I think I might have made a mistake here. Yeah. How do I? Yeah, I made a mistake here. You know, it's fine. I need to do this where north cows, not count, cows of north count equals to new coordinate of, let's just put dummy values in there. And could also do here is just put this inside here to make this shorter. That makes more sense. There we go. And we're gonna do the same thing here. First, instead of north, it's gonna be east. Input, yes. Okay, that should be correct. Okay, I'm gonna go eat and I'll be back. Okay, I'm back. Let's continue with the problem here. Oops. Camera fell again. Okay, cool, awesome. Let's continue the logic. If I remember where I was. Yes, we have an intersect here. And in the intersect coordinate, what we're gonna look at is distance from the cow to the intersect point, right? So for the east cow, the distance from that east cow to the intersect is going to be the difference of the x value, right? Obviously. So we're going to say, and for the north cow, it's going to be the y value. So if x dot x, so intersect dot x minus x dot x is greater than y comma y. Cool. So if that is true, that means that the north cow is closer to it than the x cow. So what we're gonna do then is show that the x cow needs to stop here. So Boolean stop, and what we're gonna do is set this to true. So when we begin, it's always gonna be true. Okay. But here, if that is the case, then we're gonna do it so that x that stop equals to false. Now this is gonna tell us that that cow is now stopped. So we're gonna stay here is if x, no, here, if x that stop, and we're gonna put not there because we want to check if it's false. If it is false, then we're gonna continue here to stop here, and that should be it. And else, what we're gonna do is stop this cow, right? So we're gonna do continue, but from not from here, but from all the way up here. So we're gonna say this is north cow stop. Okay. I did not mean to do that. Okay, there we go. Continue. North cow stop. Like such, so that we could go to the next cow. Okay. In this case, what we're gonna say here is int grass eaten. And we're gonna put grass and grass equals to 0 for now. Okay, I don't think we need to put this here actually. Oops, did I mean to do that? Yes, we'll just keep it like that. Okay, and here what we're gonna do is x.grass is equal to, because we now need to update this, x.grass is equal to the distance that the cow has traveled, right? So intersect x minus x. Let me think of that real quick just to make sure. Yes, that is correct. Okay. So that's kind of like what we have here. And if the y stops, we make so that y dot grass is equal to intersect y minus y comma y, which I think that makes sense, right? And we're also gonna set y dot stop equals to false. Okay, cool. So now what I'm going to do actually is set this -1 for purposes that we'll see later. Anything else we need to do here? If we do this, I think we should be good. Yeah, I think we are actually done. I mean, not like done, but like done with this part of the logic. So after all of this, how are we gonna actually like do the rest of the problem? So right now we have east cows array and north cows array with all the cows, and each of the coordinate objects have the grass integer. So we could just read off that for the answer, right? But we don't know which cow is what right now. So what we're gonna do here is actually add a int num, and we're just gonna do num just to enumerate the cow so that we know which cow is what. And what we're gonna do here is gonna put I. Cool. And for this one, we don't need a enumeration, so we're just gonna put -1. Okay, awesome. Now that we have this, one thing I forgot to do actually is sort the array so that we go from left to right and bottom to up. So how we're gonna sort that here is gonna be by creating a custom sorting array. And how we're gonna do that is, let's search it up together. So custom sorting Java. Let's go to the first link. Okay. So something like this. If we look at this here, we're gonna have 3 students in the array list, and we have this unsorted list. But collections that sort AR, comma, new sort by role. So if you look at sort by role, there's gonna be a class that implements comparator and then initializes a compare class and does a subtraction just to say if it's negative, 0, or positive. And so that's gonna be how we're gonna make our thing. So let's just take this, put this in our array, and we're gonna say north cows and new. This class is gonna be class cow sort. And the array that we need is method that we need is gonna be called compare. And it's gonna core A and coordinate B. Okay, I don't know what's happening with my typing today. It is just not working. Okay, and then we're gonna return this and that. No, like this. cow X sort. Let's do that. Okay, and for the second one, we're just going to do Y sort and A comma Y minus B comma Y, like such. And we're going to do, since this is north, we're going to do Y sort, and we need to import collections. Why isn't this working? Okay, I'm gonna solve this problem real quick and I'll be back. Okay, I'm back. I was able to fix it. How I did this was something with just using arrays was messing it up, so I kept this the same because I did change it a bit. So I would say use this kind of sort where you just have the array and then you make a new method for the comparator, or not method, new object comparator of core, and then this will be the way you compare stuff, double.compare ax and bx, and here ay by, same thing. And the biggest change was changing this to array list instead of a list to make this work. That means I had to, change this a little bit, change that a little bit just to make it, usable for a array list. That is not the code. And here as well, I need to change this to .get. But other than that, there was really nothing much that I need to change, surprisingly, which I think, these are the kind of scenarios where making this kind of thing is useful, because if I didn't make that, I'll need to change here, everything to fit to array list. But since I was able to make a object here, I didn't need to do all that. Okay, so as I was saying before this, I have all this now done. This is sorted too, so all I need to do now is basically find the answer, right? What I'm going to do is make an int array of n's, new int array of n, and what I'm going to do is I'm going to go through 0, I is less than, let's say, is cows that size. Now that it's a array list, I have to keep that in mind. And ands of position is cows that get I that num. Okay, that is equal to is cows that get I, comma grass, which makes sense, I hope. And I'm gonna do the same for north cows. And paste that in for north, and that should make sense. And when everything for that is done, what I'm going to do is I'm just going to 0, I is less than n, I is plus, and print sysout ends. But remember how there was infinities, right? And I set this to -1. So if this is -1, if ends of I equal to -1, then print infinity. But else, I'm going to print whatever I was printing, which is the number. This should work because it is such a complicated algorithm. We wrote like over 100 lines. Could be a error in it, I guess. So let's label this output. And now I think about it, instead of using this, let's use PW. Okay, let's hope for the best here. Let's see what happens. Okay, let's run this. Are there any errors here? No, surprisingly. That's a good sign. And let's go into StuckInARut and put this in. Hopefully this works. No. No such element, line 22. There's gonna be an error with this. Okay. Oh, that's interesting. Oh, yes, I need to do this to get to the next line. Okay, that should be right. So it was saying no such element, and that's because tokenizer was asking for a new token, but there's no more tokens in that line. So I need to put this line in there to make sure that it knows we're going to the next line. Let's run this. Paste that in. And that is not right. Okay, what? I see. Let's look at this problem a little bit and I'll come back. Okay, after a lot of debugging, I'm back. I figured it out. Everything here, this equals. And this equals needs to be dot equals instead of just double equals, obviously, because it's a string. It's a little mistake from my part. And I was basically messing everything up because these aren't getting counted correctly and these aren't getting put in correctly. If I'm not mentioning anything here, the code is in the description for the code backlog, so you could refer to that to fix your code. I apologize. And so, since we're at this point, let's see what's happening here. After those changes, we have this, where we have almost the right answer. 5, infinity, 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 2, 5. The answer is supposed to be 5, 3, infinity, infinity, 2, 5. So this number 2 is the only one that's wrong, which is north going 5, 3. Okay, let's see what's happening here. So why would that one north not be getting updated? Every single north. Which is a y. Xx is greater than y of x. Continue. I'm just going line by line here to check if there's anything I'm missing. Okay, I'll pause and come back. Okay, I think I might have found the problem. I think by accident I put this as east instead of north and that as north instead of east. And let's just double check that everything is correct for that. So I is gonna be north. Okay, so let's switch those two. And we need to check if x is gonna be a stop. That's correct, so we continue there. And if xx is greater than y of x, that should be correct. Yes, I think that is correct. That's correct, that's correct. And yes, let's see if that works. Okay, something is not right here. That is not right. I'll be back. Okay, cool. Yes, I got it. So, line 67, else if, that used to be just the else, but if you remember on our iPad here, condition 1 was that condition 2 was that if they're the same distance, they keep going, so we need an else if, so that we account for them being equal. And finally, last one, I made a problem with the collection sort here. We need to go from greatest to least greatest, so there should be an x instead of y because we need to compare, there should be a y instead of an x here because we need to compare how high they are, and here should be a x instead of y, we need to compare how far they're from 0 horizontally. So if we test this, this should work. Test this here, we're gonna see 5, 3, infinity, infinity, 2, 5, which is finally correct. Okay, that took way too long. That's kind of like what's gonna happen during competition, to be honest, because you are gonna be under more stress, and stress makes you dumber than you think. Just the universal rule. Okay, let's actually try to put this into USACO and see if it works. And it logged me out again. Cool. Let's see. Java, choose file, and StuckInARut. Let's see if this works. Hopefully it does. Oh, wait. Okay, I did a bit more testing, and another edge case came up. So you know how we checked here if that cow is to the left of the thing, but there's another case that we need to account for. We need to account for if the east cow is below the north cow, because if in that case we're gonna intersect either. So to check for that, we're gonna do east cow's y is less than the north cow's y. If that's true, we also continue, I believe. Let's look at this here. Okay, what the heck's happening? Okay, there we go. And if we put this here, I believe that's gonna work. And here's another case that I pulled out. I believe that's gonna work too. And that should be all infinity. Yes. Okay, let's put it into the website. Java file, StuckInARut. And if we upload this, let's wait. Oh, I need to delete the prints. Fair enough. Yes, if we put this in here. Okay, yeah, that should be fine. Yes, that should be fine. Okay, let's try that again. It's past 12 o'clock right now, so I need to finish this soon. And yes, finally, it is over with all of them taking about 60 milliseconds. Very nice. And that will be it for Bronze 2020 December. Problem number 3, StuckInARut. And if you want to look at the other problems, the code is here for daisy chains. And code is here for do you know your ABCs. This last problem was definitely a bit tough. 112 lines in total and a lot of time troubleshooting. So all these codes, as I said, will be in the description, and I'll see you guys next time. Bye bye.